All right, here's example 2.6. I'm going to show you two different ways to solve this problem. What you are asked to do, actually, I'm not going to show you two different ways to solve this problem. I'm going to show you two different ways to find the slope-intercept form of the line that goes through these 2 points. But the way your book wrote this, it asks you to do this one specific way by using the point-slope form of an equation to get there. So I will do that, and then I'll show you another way you can solve this problem had this first sentence not been there. So, okay, either way, regardless of which of these two methods you use, your first step is to find the slope. And to find the slope, you arbitrarily label these points. You can call this point the x1 and y1 or the x2 and y2, and then this is the other one. And you remember that the slope of a line is the difference in the y-coordinates over the difference in the x-coordinates. And so if you go plugging in points, y2 is 7 minus y1 is 1 divided by x2 is 8 minus x1 is 5. So it looks like I got 6 over 3, which is 2. So I know that the slope is equal to 2. And that'll be useful regardless of which of the methods I use. I'm going to do this the way your book did it first, where you're asked to write the point-slope form of an equation. And so for that, you have to know the point-slope form looks like this. Note, if you have trouble remembering point-slope form, if you divide both sides of the equation by this thing, the x minus x1, it looks a hell of a lot like this formula here, just kind of without the 2's in there. It can help you remember what goes where in this formula. At any rate, I know what m is. I solved for that over here. It's 2. X and y I'm just going to leave as x and y. So all I got to do is fill in x1 and y1. And I figured out up here, well, really you could use either of these 2 points here, but to be consistent, since I called these x1 and y1 before, I'll call them x1 and y1 again. Although there's no problem using these 2 points in here. Y1 is 1. X1 is 5. So this right here is the point-slope form of the equation. But I'm not done. This is usually not where you'll leave your answer. And the reason why is this isn't kind of the standard way you write a line. The standard way is what's called slope-intercept form. And slope-intercept form is that y equals mx plus b thing. However, algebraically, you can make this look like y equals mx plus b. Well, y equals mx plus b doesn't have any parentheses, so let's get rid of those parentheses first. Make this 2x minus 10. And then y equals mx plus b has the y all by itself. So let's get the y all by itself. Let's add 1 to both sides of the equation. You get 2x minus 9. This right here is the answer. And this is the method that your book used to solve this answer. Alternatively, and this will only work if you were not asked to write the point-slope form of an equation. If you just want point-slope form, slope-intercept form, you could also say slope-intercept form is y equals mx plus b, and I solved to figure out m was 2, so really I have y equals 2x plus b, and if I could just figure out b, I'd be done. And to solve for b, I can take either of these points and plug them in for x and y. So if I take this point, I'd say the y is 1 and the x is 5. So I got 1 is 10 plus b. So therefore b, if I subtract 10 from both sides of the equation, is negative 9. And now I have all the pieces I need to jump to this form right here. So y equals m is 2, x plus b is negative 9. So I get the exact same answer I got before here without going through point-slope form.